Roughly 12,800 years ago, the world was finally getting warm again. The great ice sheets that had smothered the northern half of the planet for tens of thousands of years were breaking apart at their edges. Melt water was pouring off them in braided rivers. Grasslands were spreading north into ground that had been frozen for as long as any living thing could remember. And then, in what may have been less than a single human lifetime, some evidence suggests within just a few decades, the warming stopped. It didn't slow, it reversed. The cold came slamming back down like a door swinging shut, and the ice that had been retreating began to grow again. That sudden reversal left a mark in sediment across 3, arguably 4 continents at almost exactly the same depth. Researchers keep uncovering a thin, dark band, a line. In some places, it's a smear of black organic soil no thicker than your finger. In others, it's a faint dark seam pressed between paler layers of clay and sand. But the strange thing, the thing that has kept scientists arguing about it for the better part of 2 decades, is what sits on either side of that line. Dig below it and you find the bones of giants, mammoths, mastodons, ground sloths the size of cars, the stone spear points of a thriving, widespread human culture. Dig above it and almost all of that is gone. The giants have vanished. The spear points stop. It's as if someone drew a single stroke across the surface of the entire planet. And on one side, there was a full teeming world, and on the other side, there was an emptied one. For nearly 20 years, geologists, archaeologists, and physicists have fought over one deceptively simple question. What is that line? What actually happened at the moment it was laid down? And the reason the fight has been so fierce is that the answer might explain not one mystery but 3 of them stacked on top of each other. 3 catastrophes crowded into the same narrow window of time. This is the story of that black line, of the people who kept going back to it, and of what happened when a new generation of scientists stopped arguing about the story and went back to reread the layer itself, measuring it with tools no earlier study could bring to bear. What they found didn't crown a winner. It did something more interesting. It reframed the entire debate. To understand why that line matters, you have to picture the world just before it appeared. Rewind to around 14,000 years ago. The planet was in the middle of a long, mostly steady thaw. Coming out of the depths of the last ice age, temperatures had been climbing for thousands of years. The enormous ice sheets that in places had been more than a mile thick, were in retreat, releasing land, releasing water, releasing life. And into that opening land came the Megafauna, the great animals of the ice age. Herds of mammoths moved across the cold grasslands, tearing up frozen grass with their trunks. Mastodons browsed the spruce forests. Giant ground sloths reared up to strip leaves from high branches. Dire wolves hunted in packs. There were camels. Yes, camels native to North America alongside horses, giant beavers, and longhorned bison twice the size of anything alive today. For thousands of years, the trend held in one direction. Warming, thawing, life spreading into ground that had been locked in ice. If you had been standing on those plains, watching the seasons turn across the generations, you would have seen a world slowly, steadily opening up. There was no obvious reason to think it would ever stop. And that is exactly what makes what happened next so hard to explain. Because roughly 12,800 years ago, that long, patient warming didn't just pause. It flipped. The temperature crashed back down toward glacial cold. Ice began advancing again across regions that had only just been freed. And this bitter cold snap didn't last a season or a decade. It gripped the northern hemisphere for something like 200 years. Scientists gave this cold period a name, and it's a curiously delicate one for such a violent event. They call it the Younger Dryas. The name comes from a small Arctic wildflower, Dryas octopola, an 8-petal white bloom that clings to cold, high open ground. When that plant grows, it drops pollen, and that pollen ends up preserved in the mud of lakes and bogs. When researchers drilled down through northern European sediments and studied the pollen trapped inside, they found that at this particular slice of time, cold-loving plants like Dryas suddenly surged back. Warm-loving trees retreated. The pollen was telling a story. The cold had returned hard and fast right at that layer. And so the wildflower gave its name to the whole grim episode. But the flower is only a marker. The real puzzle is the abruptness. After thousands of years of steady warming, why would the climate lurch backward almost overnight? And here is where the mystery deepens. Because the Younger Dry doesn't stand alone. In roughly the same narrow window of time, other enormous things were happening. Things that seem far too big and too neatly clustered to be pure coincidence. Around the same period, North America lost most of its largest animals. The mammoths, the mastodons, the ground sloths, the native horses and camels. A huge share of the continent's Megafauna disappeared, and they did not come back. And it wasn't only the animals. A widespread, sophisticated human culture that had spread across much of the continent also seems to fade out right here at almost exactly this moment. 3 major events, an abrupt climate reversal, a wave of extinctions, and the collapse of a human way of life, all crowding into the same tight band of time. When 3 catastrophes line up that closely, scientists start to wonder whether they might share a single cause, whether something happened once that set all of it in motion. The human culture caught in that window has a name, too. Archaeologists call them the Clovis people after a small town in New Mexico where their distinctive tools were first identified in the 1930s. And distinctive is the right word because the Clovis toolkit is unmistakable. Its signature is a stone spear point unlike anything that came before it. A beautifully worked leaf-shaped blade with a long groove called a flute chipped up from the base on both faces. That flute let the point be seated firmly into a wooden shaft. It was a piece of precision engineering, and it appears across an astonishing sweep of North America from the plains to the eastern woodlands, made in essentially the same way everywhere you find it. These were people who had solved a problem and solved it so well that the solution spread across a continent. And what problem had they solved? The problem of killing something enormous. The Clovis point was built for big game, for driving into the hide of an animal that could weigh several tons, for hunting the very megafauna that roamed the open grasslands of that warming world. This was a people whose entire way of life was wrapped around the giants. They followed the herds. They read the land. They knapped their tools to bring down mammoth and mastodon. And everything about their culture, their mobility, their weapons, their knowledge was tuned to a landscape full of enormous animals. For generation after generation, that toolkit worked. It was passed down, refined, carried across rivers and plains, and it kept feeding families because the world it was designed for stayed more or less the same. And then, in the space of that narrow window, the world it was designed for came apart. When the giants collapsed, the Clovis people lost the very foundation of their existence. Imagine spending your whole life mastering a craft, inheriting it from your parents, and teaching it to your children, and then watching the thing that craft depended on simply vanish from the earth. The fluted point that had fed a continent no longer fit the landscape. There were no more mammoths to hunt. The camels were gone. The horses were gone. A toolkit that had been unchanged and unchallenged for centuries suddenly had nothing left to point at. And so, right at the boundary, the Clovis signature fades from the archaeological record. Later peoples would come and they would make different tools for different prey, smaller points for smaller game, for a different world. But the Clovis way, as it had been, was finished. So we have this eerie convergence all compressed into the same slice of sediment. The cold slamming back, the giants dying out, and a human culture dissolving. And it turns out there is a physical thing you can point to that seems to draw the line between the world that was full and the world that was empty. For decades, one geoscientist in particular documented a strange dark layer that kept appearing at site after site across North America. It's a thin band of dark organic-rich sediment, and it shows up at the base of many stratigraphic sequences precisely at this depth. This age researchers came to call it the black mat. And what makes the black mat so haunting is not just its color but what sits on either side of it. Below the black mat you find the bones mammoth remains the scattered evidence of a rich living ecosystem, and mixed into those lower layers. Again and again you find Clovis points, the tools of the hunters lying in the same soils as the animals they hunted. But then you reach the dark band, and in it and above it that world is gone. No more mammoth bones, no more fluted points. The black mat behaves almost like a line ruled across time itself, a boundary you can put your finger on with a full and thriving world underneath and a strange emptied silence above. Whatever happened, it happened here at this layer, and that is what has drawn scientists back to it for the better part of a century, running their fingers along that dark seam and asking the same question. What is it and what does it mark? For a long time, the honest answer was that no one fully agreed. The black mat itself has a fairly conventional explanation. It's the kind of dark organic layer that can form when the water table rises and wetlands spread, soaking the ground and preserving organic matter. That on its own is not exotic. Wet, boggy conditions can lay down dark sediment without any need for catastrophe. But the timing kept nagging at people. Why should this layer forming across so many places sit at almost exactly the moment that so much of the living world disappeared? Was the dark band merely a coincidence of climate and chemistry, a passive record of a cooling, wetter world? Or was it something more, a scar, a signature of whatever event had thrown the climate into reverse and swept the giants away? Then in 2007, a group of researchers published a paper that took that quiet geological puzzle and turned it into one of the loudest arguments in all of Earth science. Their claim was audacious. They proposed that the Younger Dryas had not begun with some slow internal shuffle of ocean currents or ice sheets. It had begun, they argued, with a blow from the sky, a cosmic event, a comet or a cluster of fragments from one or an asteroid striking or exploding over the northern hemisphere somewhere near or above the great ice sheet that still covered much of North America. In their telling, this was the trigger. The impact or air burst would have unleashed enormous energy, ignited fires, thrown debris and dust into the atmosphere, and destabilized the ice. And from that single violent moment cascaded the cold, the extinctions, and the collapse of the Clovis world. It was in a sense an elegant idea, one cause for three mysteries, a single catastrophic instant that could explain explain why everything seemed to end at once right there at the black mat. But an idea that bold does not get accepted on elegance alone. And it wasn't. Almost immediately, the hypothesis ignited a fierce sustained debate, one that would run for well over a decade and in some corners is still burning today. Because for every line of evidence the impact team put forward, a chorus of skeptical scientists stood up to ask harder questions. Where they wanted to know was the crater. Where was the undeniable smoking gun that any impact large enough to reset a planet's climate should have left behind? The Earth keeps a record of its great collisions. It carries scars, circular basins, music rings of shattered rock, buried craters that show up in the gravity maps and the drill cores. And yet here, for an event supposedly powerful enough to tip the whole northern hemisphere back into an ice age, there was no obvious hole in the ground. No neat, unambiguous bowl gouged into the continent. The impact team had an answer for that. The blow, they suggested, might have landed on the ice sheet itself. Kiln of glacial ice that has long since melted away, taking any crater with it. Or the event might not have been a single impact at all, but an air burst, a body detonating in the atmosphere before it ever touched the ground, releasing its fury as heat and shock wave rather than carving a pit. It was a reasonable reply, but to the skeptics, an explanation that conveniently erased its own most important piece of evidence was exactly the kind of argument that demanded caution rather than belief. So, the two camps did what scientists do when the story itself has become a shouting match. They stopped arguing about the narrative and went back to the thing at the center of it all, the layer. If the impact hypothesis was right, then the boundary sediment should carry the fingerprints of extreme heat and cosmic material, not vague impressions, but specific, measurable physical signatures that ordinary Earth processes could not easily fake. And so at sites across North America and beyond, teams began carefully excavating that thin, dark seam, bagging it, labeling it, carrying it back to laboratories, and putting it under instruments far more sensitive than anything the earlier generations of researchers had ever possessed. What they were looking for first were tiny spheres. When rock or soil is flash heated to extreme temperatures, the kind of heat a large impact or air burst would produce, some of it melts. And as those molten droplets fly through the air and cool, they freeze into tiny beads. Microspherules, they're called. Some are rich in iron and carry a faint magnetism. Others are glassy carbon. Under a microscope, they look almost artificial, like impossibly small ball bearings scattered through the dirt. The impact teams reported finding them concentrated right in the boundary layer in numbers that spiked sharply at that depth and fell away above and below it. To them, this was the signature of a moment of intense, widespread heating, a pulse of fire written into the sediment. But sparules alone were not enough because nature has other ways of making little round beads. Volcanic activity can produce them, so can ordinary wildfires under the right conditions. Even industrial pollution and cosmic dust that constantly drifts down onto the planet can leave microscopic spheres in the soil. A skeptic could look at the same beads and see a dozen mundane sources. So the search went deeper down to the level of individual crystals, hunting for something far harder to explain away. Nanodiamonds. Diamonds so small they are measured in billionths of a meter. Invisible to any eye, detectable only through the way they scatter beams in specialized instruments. Diamonds form under crushing pressure and heat, and certain rare forms, including a hexagonal variety associated with the violent shock of an impact, are exceptionally difficult to produce by any gentle everyday process. The impact team announced that they had found these two threaded through the black mat. If that held, it was a powerful thing to hold because it pointed toward pressures and temperatures that simply do not occur when a wetland floods or a grass fire sweeps a plain. Then came the piece of evidence that would prove the most durable of all. And it came not from the muddy floor of a dried-out American pond, but from the frozen archive at the top of the world. In the ice of Greenland, where snow has piled and compressed year upon year for tens of thousands of years, scientists have drilled long cylinders of ancient ice cores that preserve layer by layer a chemical diary of the planet's past. One of these famous cores had already given researchers a stunningly precise record of the Younger Dryas onset, showing just how brutally fast the cold had arrived. But when a team went back and measured that same ice with an eye for one particular element, they found something that made even cautious observers pause. Platinum. Right at the boundary, precisely where the climate had flipped, the platinum concentration jumped. It spiked sharply and then subsided. Platinum matters here for a simple reason of cosmic bookkeeping. In the outer crust of the Earth, platinum is genuinely rare. Most of the planet's original supply sank long ago into the iron heart of the core, dragged down when the world was young and molten. But out in space, in the bodies that form differently, platinum is far more abundant. Comets and asteroids carry it in proportions that Earth's surface almost never shows. So, a sudden sharp enrichment of platinum appearing in a thin band at one specific moment in time and nowhere else in the surrounding ice is exactly the kind of thing that makes a geochemist sit up. It looks like the delivery of extraterrestrial material. It looks like something fell and the platinum did not stay confined to Greenland. silent. As other teams began testing sediments at sites scattered across North America, targeting that same boundary interval, the anomaly kept reappearing. Site after site, separated by hundreds and thousands of kilometers, showed the same fingerprint, a rise in platinum right at the Younger Dryas onset. It was this pattern, more than the spherules, more than the contested diamonds, that some researchers began describing as the closest thing yet to a smoking gun. Because a single strange spike at one location can be dismissed as contamination or local chemistry or bad luck in the lab. But the same anomaly at the same moment in time turning up again and again across a continent is much harder to wave away. It begins to look less like coincidence and more like a signal, a whisper of the same event recorded independently by many different patches of the Earth's surface, all of them holding their breath at the same instant 12,800 years ago. And if the event had truly been that large, that violent, then its reach should not have stopped at the edge of North America. It should have left marks farther afield. Music, and that is exactly where the next and perhaps most startling piece of the puzzle would come from. In a place where the story was no longer only about vanished animals, but about people and a village and the ground beneath their feet turning to glass. That village was Abu Huraira in what is now Syria, one of the earliest places on Earth where human beings were making the slow, momentous turn from hunting and gathering toward settled life. People lived there at the very edge of the Younger Dry in round huts, grinding wild grains, tending the first tentative experiments in cultivation. Their story matters on its own terms. But when researchers examined the sediment layer that corresponds to the boundary at Abu Huraira, they reported something that stopped them cold. Melt glass, fragments of soil that had been heated so violently they liquefied and then froze into glass, carrying inside them the chemical signatures of the very ground they had once been. The local minerals, the building materials, even traces of cultivated plants, all fused together at temperatures far beyond anything a cooking fire or a burning hut could produce. The interpretation offered was extraordinary. Not a strike, not a crater carved into the earth, but an air burst, a cosmic body exploding low in the atmosphere, close enough to the surface that the blast of heat and pressure reached down and melted the ground itself. If that reading is correct, then the event recorded in the North American black mat and in the Greenland ice was not a single local catastrophe. It was hemispheric. It touched a farming village in the Near East and a mammoth hunting culture in New Mexico within the same narrow window of time. Two peoples separated by an ocean and by ways of life that could hardly have been more different, both marked by the same thin, dark, glassy signature in the earth beneath them. And there was one more layer to the pattern, literally a layer of burning. At many of these boundary sites, researchers reported a sharp peak in the markers of fire, charcoal, soot, the chemical residue of vast quantities of vegetation going up in flame. They described it as one of the most intense biomass burning episodes of that whole era, as though continents' worth of forest and grassland had ignited in a geological instant. And that carries its own dark logic. Enough smoke lofted high enough into the atmosphere could dim the sun for months or years. An impact winter, a shroud of soot that cools the planet by starving it of light. It offered a mechanism, a way to connect a cosmic event to a sudden plunge into cold that lasted 12 centuries. So here is the honest turn, the place where this story refuses to become simple. Because for every one of those findings, there is a serious credentialed voice on the other side, and they are not cranks. The leading rival explanation for the Younger Dryas needs no comment at all. It says that as the great ice sheets melted, an enormous surge of cold freshwater poured into the North Atlantic and disrupted the ocean currents that carry warmth northward. And when that conveyor faltered, the northern hemisphere plunged back into cold. No sky, no explosion, just water and physics. As for the vanished giants, critics point to human overhunting, to the whiplash of the climate itself, even to disease, as causes that need no impact to explain them. And when other laboratories tried to reproduce some of the microscopic evidence, the spherules, the rarest nanodiamonds, they sometimes couldn't. They found ordinary sources for particles that had been called extraordinary. They questioned the dating. They asked reasonably where the crater was. That is why no single experiment has ended this argument. And honestly, none may ever do it alone. But notice what has survived nearly 2 decades of that scrutiny. The platinum spike held up, measured, replicated, appearing across a continent and locked into the Greenland ice at precisely the right moment. The melt glass held up as something that demands a genuine explanation. And the dating Titan site by site keeps pointing at the same instant. Those are not proof of a comet, but they are real facts sitting in the layer waiting for any theory that hopes to describe that boundary to account for them. And we know such things are possible because the Earth has shown us a smaller version within living memory. In 1908, over Tunguska in remote Siberia, something exploded in the sky. No crater, no meteorite recovered, just a cosmic body detonating in the air. And in that single silent flash, it flattened roughly 80 million trees across more than 2,000 square kilometers of forest. No impact site to find, only the devastation and the puzzle of it. If a modest air burst could do that to Siberia in a heartbeat, the question the younger dry layer poses stops sounding like fantasy and starts sounding like arithmetic. So the black line still runs across 4 continents, thin and dark and stubborn. Beneath it, mammoths, mastodons, sloths, and the graceful fluted spear points of a people who thrive. Above it, an emptied, colder world, and in the layer itself, platinum and glass and ash that no one has fully explained away. The debate isn't broken because one side won. It's broken open, cracked into a sharper, more honest question than the one we started with. Something real happened at that boundary. The mystery is no longer whether the layer holds a signal, but what exactly reached down and left it there. So, I want to hear from you. Standing at that thin, dark line, looking at the platinum, the glass, the sudden cold, what do you think ended the warming so abruptly 12,800 years ago? A comet in the sky or an ocean losing its rhythm? Tell me in the comments which answer you find harder to dismiss. And if you were handed one core sample from that boundary and one instrument to read it, what would you test for first?